So for long form review 2, we're going to incorporate distributive and opposite of a sum. And that means we're going to have expressions within the equation that need to be simplified. And you do typically want to simplify both sides of an equation or both expressions before you solve. So our first equation that we'll do together is 8 times the difference of 3x and 6 is equal to 16. So that'll be our given. And again, you want to hopefully look at that and say, okay, this left-hand side is not simplified. And we do want to simplify before we solve. So that means combining like terms and eliminating any groupings. So to eliminate the groupings, we need to kind of distribute that 8. I'm going to change the subtraction first. It's always a good idea to get rid of subtraction if you can. And so, of course, that is going to be by changing our subtraction to adding the opposite. And that's definition of subtraction. And definition of opposites. Now, I am going to do definition of opposites later, so I could save that and change it later, but I don't like a lot of extra parentheses kind of lying around. So I like to change mine right away. All right, and then to get rid of those groupings, I am going to need to kind of share that 8 with everything inside that group, and that is that distributive property. So now what was in parentheses, typically we like you to leave in parentheses until you change it with a grouping property. So sharing that 8 is distributive. And then in order to make the 8 times 3 first in order of operations, we would need to use a grouping property. I'm just going to change the grouping in the other multiplication as well. And that is the associative property of multiplication. And that makes the multiplication first in order of operations. So I can go ahead and do that on both sides, in both multiplication problems. And that is just substitution. And so now I have simplified expressions on both sides of the equation. And that's where we want to look at, okay, when I solve, I want to undo order of operations. So if I knew what x was, then the multiplying in between the 24 and x would be first, and then the addition would be second. But to solve, I want to undo that. So I want to take care of the addition first. And to do that, I'm going to add the opposite of negative 48 to both sides, which means I'm going to add 48 to both sides. So what I had on the left-hand expression was 24x plus negative 48, and to that I'm going to add 48. Now, of course, I have to do that on the other side of the equation as well to keep it equal, and that's the addition law of equality. Now, my goal is in this process here is to kind of get rid of those, so I need to change the grouping to make that addition first in order of operations. So I changed the grouping there, and that's associative of addition. That allows me to change the grouping of addends without changing the sum. And then I can go ahead and add those. And since they are opposites, we do get 0. And that's additive inverse. And then, of course, adding 0 to 24x just leaves us with 24x. And that is additive identity. And then I want to do the addition on the right-hand side to shorten that up. That's going to give me 64, and that's just substitution. And so now I'm down to kind of stripping things away from x. I need to just get rid of the 24 times x. So to do that, I want to multiply by the inverse of 24, which is, of course, 1/24. And I would have to multiply by 1/24 on both sides of the equation. So that's a property of equality, multiplication property of, or multiplication law of equality. And then to make the 1/24 times 24 first in order of ops, I want to change the grouping. And that is associative of multiplication. That's going to be 1x is equal to 1/24 times 64, and that is multiplicative inverse. I'm just going to come to the top of the page here. And so I end up having that 1x is just going to be x, and that's 1/24 times 64, and that is multiplicative identity. I can drop that 1. And then when I multiply 1/24 times 64, if you do that using your calculator, you're going to see that you get 2.6 repeating, which is correct. But when you have a repeating decimal, it's most of the time, algebraically speaking, going to be best for you to leave it in fraction form. So I'm going to leave that as 8/3. And then, of course, we do our check. So to do our check, we go back to our original given. And your check we don't need you to do in long form, so you can go ahead and we're going to just plug in for x our 8/3. And we can, when you're multiplying fractions, you can give that whole number a denominator of 1. And so hopefully realizing that you can cancel that numerator and denominator. And so we end up with 8 times the quantity of 8 minus 6 is equal to 16. Again, you can do that using your calculator, but hopefully realizing why that works. And then we get 16 is equal to 16. And always good when we're doing our check, that's what we're looking for, trying to make sure we get the same thing on both sides. So what we realize is that our solution set is in fact 8/3. And so we can put those in set braces. And that's our review again, just kind of looking at, if we go back to that line with distributive in it, like that's our kind of focus for that, is that this property was kind of the new review that we were doing, was sharing that to simplify your expression before you solve. We're going to do one more, so if you need a little more space, you want to get that, and I'll erase my board here, and you get ready for the next one. So this new equation looks a lot like the last one, but hopefully noticing that we are subtracting the quantity from 8 instead of multiplying 8 by the quantity. And so that's going to involve a little bit different properties and, of course, give us a different solution. We still want to make sure we are simplifying expressions before we solve, and that expression on the left is not simplified. So we want to take care of our subtraction. So let's go ahead and do that. We have 2 subtractions we can undo with definition of subtraction. So I would change that first subtraction to adding the opposite. And I'm going to use that same property inside here to take care of that subtraction with the minus 6. And I can do that both at one time since that's the same property. So definition of subtraction there. And then inside the parentheses I have the opposite. Again, I don't like a lot of extra parentheses kind of hanging out, so I'm going to take the opposite of that 6 and make it -6. And that is just definition of opposites. That could wait for later, but I like to get rid of those parentheses. Now, what we have here is we have that opposite sign outside of a whole sum. And that's where we would use the property opposite of a sum. It looks a lot like distributive, and mathematically it really is like distributing a -1. So if you would like to put in, use multiplicative identity and put in a coefficient of 1, you could do that, and that would be multiplicative identity property. And then you could distribute -1, just like you used distributive in the last one. But I'm going to show you the example of opposite of a sum, so I'm going to take that one out. And kind of use op sum. So that means I'm going to share that negative with each piece of the sum. So that means I'm going to take the opposite of each term, so that's the opposite of 3x, plus, and then I'm going to share the opposite of the negative 6 that was in there. And that is the property opposite of a sum. It just means that we can do that without changing the value of that expression. And then because I have the opposites of two terms in there, I'm going to use definition of opposites to kind of get rid of those parentheses. Of course, the opposite of negative 6 is 6. And that is just definition of opposites in two places there. Now I want, again, to simplify before I solve, and these are like terms. So I want to get those next to each other, make them first in order of operations. And to do that, I need to move some things around. So I'm going to move those two like terms next to each other. And moving that, being allowed to move those add-ins without changing the sum is commutative of addition. Now it's really tempting, and you know, when we're not doing long form, we could mentally just add these two terms together. You know that you can add them, but they're not first in order of operations right now on that side. Technically, first in order of operations is the multiplying between the negative 3 and x. So we need to do a little property maneuvering to make that addition first. And so we just want to regroup. And that makes the addition first in order of operations, and that's associative of addition. And now that it is first, we can go ahead and do that operation. And that is just substitution. Now, since we've got the expression simplified on both sides of the equation, we can start thinking about solving. And remember, solving when we kind of undo order of operations. So if I knew what x was, the multiplication would be first and the addition would be second. When I'm solving, I want to undo that. So I want to take care of the plus 14 first, or get rid of the plus 14 first, which means I'm going to add its inverse to both sides. So I'm going to go ahead and add negative 14 to both sides of the equation. And that is the addition law of equality, or addition property of equality. Now I'm going to regroup, again, just to make adding those opposites first in order of operations. And that's associative of addition. Adding those two terms gives me 0. And that would be additive inverse. And then 0 plus negative 3x, just giving me negative 3x, is the additive identity property. All right, so then just kind of transferring up to the top of the page here, I'm going to take care of the adding on the right-hand side. So I'm left with negative 3x is equal to 2. And that would just be substitution. And so with the x, now I just have negative 3 times that, which means to get rid of the multiplication, I want to use the multiplication property and multiply by that inverse on both sides. So I'm multiplying by negative 1/3 times negative 3x. Remember, the inverses, multiplicative inverses have the same sign. Now I need to multiply by negative 1/3 on both sides. That's the multiplication law of equality. I can multiply the same quantity on both sides without changing the value of the equation. And then to make that multiplication first in order of operations, I need to regroup. That's associative of multiplication. And get 1 as my product there. And that's multiplicative inverse. And here I get negative 2/3 as substitution. And I can get rid of that coefficient of 1 with multiplicative identity. Now we always want to go back and check. So I would go back to my original to do my check. I'm going to plug in my hopeful solution. Now, again, you don't need to do long form for your check, so just kind of thinking through that. Multiplying fractions, whole numbers can get a denominator of 1. You can cancel those 3's, so we end up with like 8 minus the quantity of negative 2 minus 6. Again, you may use a calculator. I'm just kind of taking you through without it, hopefully, so you can view that thought process. This would give us a negative 8 inside those parentheses. And then 8 minus negative 8, hopefully you can see you could change to adding the opposite. And you get 16 is equal to 16. And we love getting the same thing on both sides because that tells us that our solution is correct. Remember to take your questions into your teacher the next day. Enjoy your evening.